Hello everyone, welcome to my math workshop on the standard deviation. And if you happen to be new in my channel, I am Dr. Esperanza and I have 18 years of experience teaching mathematics. And for today, we're going to be learning how to compute and interpret what the standard deviation is in statistics. So stick around and learn the variance and the standard deviation from this workshop. So we worked on how to use the calculator to produce the standard deviation and the mean of a distribution. And for today, to be able to compute for the standard deviation, you will need your calculator. So you can use your phone, you can use your mobile devices, because the formula that we're going to be working on right now is going to be a little bit different from the usual formula that we used to, because we're going to find the variance and the standard deviation of a data set. And in this lesson, we're going to be using a formula. This is the formula for the variance, and this is the formula for the standard deviation. Now, what do you notice about the two formula? This one has an exponent of 2, and this one has no exponent of 2. But look at the formula. Are they identical? But since there's no exponent of 2, what do you think happened? Why the exponent was gone in the standard deviation? Because we took the square root of it. So that's the difference between the variance and the standard deviation. The variance, which is s squared, is given by this formula. And to find the standard deviation of your data set, you just need to take the square root of your variance so you can find its standard deviation. Now, this formula is full of symbols. This symbol, and the x, and the n, and the mean, and the exponent. So we're going to be using all these symbols in our lesson for the variance and the standard deviation. So let's dive in to the formula by applying it to this word problem. Let's say I'm trying to find the standard deviation of the number of siblings of my 5 students. So I had 5 students in a class, and I interviewed them and take a survey. I asked them how many siblings they have. And in this particular case, Spencer had 3 siblings, George has 2, Austin has 1, Marisol has 3, and Maria has 2 siblings. And I want to see the standard deviation of the number of siblings in my 5 students. And standard deviation, technically, it is the average differences in the individual, which I'm going to deal with in a little while. But first, let's use the formula. So to use the formula, we're going to find the variance and then the standard deviation first. However, the formula is too big, right? So the best way to use the formula is to use it in table form. And how are we going to use it in table form? We're going to find each of the values in our distribution. In our formula, we need to find the mean. Do you know how to find the mean in your calculator or using your calculator? What is the mean number or average number of siblings in this survey question? So that is your mean. And after finding the mean, we're going to compute for the standard deviation using a table. And the first thing that we need to do is to write down all our x's. And what are the x's in our distribution? The data set. So we'll have 3, 2, 1, 3, and 2. Copying down all your given number of siblings. This is Spencer's number of siblings, George's number of siblings, Austin, Marisol, and Maria. Now, in the formula, we need to use the mean as well. So we have the x. Now let's find the mean. And the mean, we already computed for the mean, and it is 2.2. So all you need to do is to plug in the mean in your mean column. 2.2, 2.2, 2.2, 2.2, 2.2. So now that we have these two columns, let's start using the formula. And in the formula, we need to find this. X minus the mean. And how are we going to compute for the x minus the mean? Let's use it on the third column. X minus the mean. Now we're going to be using our calculator and organize it on our third column. How are we going to produce x minus mean of the first data set? 3 minus 2.2. So what is 3 minus 2.2? 0.8. And you will do it to every single item. What is 2 minus 2.2? 2 minus 2.2 is negative 0.2. What is 1 minus 2.2? Negative 1.2. 3 minus 2.2? 0.8. And 2 minus 2.2? Negative 0.2. So now that we have our third column, we're going to use the next column and square our answer in the third column. So we'll be able to produce x minus x bar quantity square. And what is x minus mean quantity square? It is 0.8 square. And what is 0.8 square? 0.8 square is 0.64. And all you have to do is to square each one of them. So now we're going to square negative 0.2. And what is negative 0.2 square? Is it going to be a positive answer or a negative answer? It will be a positive answer because every time you square a number, it will become positive because essentially you're multiplying it by itself. And negative 0.2 times negative 0.2 is a positive number. So what is 0.2 square? 0.04. And then you have, this is here, this is here. Now 1.2 square, what is negative 1.2 square? 1.44. And what is 0.8 square? 0.64. And what is negative 0.2 square? 0.04. Now, what do you notice about the fourth column? Do you see any negative signs in the fourth column? No, because you are squaring all these numbers, that's why it becomes positive. So now that we're able to produce this column, we're going to apply this symbol. And what is that symbol? Add them all up. So we're going to add up all our values in this column so we can produce our numerator. So what is the total of these values? 0.64 plus 0.04 plus 1.44 plus 0.64 plus 0.04. What did you get? 2.8. 2.8. So this 2.8 represents this. We just need to figure out n minus 1. And what is n minus 1? What is n minus 1 in our formula? N is the number of data sets. How many data sets do we have? 5 minus 1. And what is 5 minus 1? Is 4. And we're looking for the standard deviation. But right now, this is just your variance. We need to find the standard deviation. And to find the standard deviation, we're going to take the square root of your data set. So that S is equal to the square root of, what is 2.8 divided by 4? 0.7. And if you take the square root of 0.7, 0.83666, so or 0.84. And that is your standard deviation. So this is how you compute for the standard deviation of a given data set. Now, it needs to be in table form because it's a lot visual and a lot more organized rather than using the formula like this. This is another way on how you can compute for the standard deviation. First, compute for the mean, which is 2.2. And after computing for the mean, write out the formula vertically. And this is how you spread out your formula, which is too long and a little bit problematic because you might end up making a mistake because of how you set up your problem. But you will still be able to find the answer you're looking for. It's just that in table form, it's a lot more visual and a lot more organized. So we have these values. Using our math, you will have 2.8 over 4, which we found a while ago. But since this is the variance, we need to find the standard deviation by taking its square root. So we'll have S equal to 0.84, which is what we found using our table. Now, we know how to compute for the standard deviation. Now, let's experiment on the standard deviation. Because most students, they can memorize the steps on how to find the standard deviation, but they don't understand what exactly is the standard deviation. If we talk about the mean, you'll be able to visualize what the mean is. Mean is just the average, right? So if we're going to compute the average height of this group of people, what is the average height of my first group with a height of 62, 61, 61, 66, and 72? The mean height is, can you please compute for it? 62 plus 61 plus 61 plus 66 plus 72 divided by 5. And I have 64.4 inches. So the average height of my first group, Liza, Michelle, Dominique, Mariano, Brian, is 64.4 inches, which is about 5'4" in height, if we're going to convert it into the American measurement. If I have a second group, Roberto, Sean, Ian, Francisco, and Tyrone, and if I need to compute for their average height, what is their average height? 73 plus 75 plus 71 plus 66 plus 71 divided by 5, 71.2 inches. Now, which one is taller between group 1 and group 2? Group 2 has a taller group of students because their average height is 71.2 inches as opposed to 64.4 inches. But that's not what I want you to work on. I want you to check which one between the two groups has a more consistent height distribution. Now, by just looking at the data set, I have 5 students here and I have 5 students on group 2. 62, 61, 61, 66 inches, and 72 inches. Group 2, 73, 75, 71, 66, and 71. Which one do you think has a more consistent height? Group 1 or group 2? If we're talking about consistency. Any guesses? I'll show you how to mathematically compute for a description that will describe which group is more consistent between the two groups. And that is the importance of the standard deviation. It will compute for the variability or the average differences in your data set. So let's see which group has a more consistent height and how does the standard deviation is used to produce that description. So we'll compute for the standard deviation. We will compute for the standard deviation of this group and the other group. So let's do this. Let's use our table. We need to produce our x's. What will be my first column in my standard deviation computation?
62, 61, 61, 66, and 72.
And 72. And then the mean is the same, 64.4. And then I need my x minus x. Okay, tell me.
Negative 2.4.
Negative 2.4.
The next one's negative 3.4.
And then?
Negative 3.4. 1.6. 7.6.
7.6. And then I need to square it. So I'll have x minus x bar square. So that means all my answer will be positive.
Yes.
What will be my first one?
5.76.
5.76.
11.56. And 11.56 again. 2.56. 57.76.
And then I need to add them up,
89.2.
which is
89.2.
alright. So now that I have my 89.2, I'm going to use the formula for S, which is the square root of the sum of the square of this all over n minus 1. So I know that this is this, right? So I have 89.2 all over, what is n minus 1?
5 minus 1.
5 minus 1, and then take the square root of that. So I have the square root of 89.2 all over 4, which gives me the square root of, what's 89.2?
22.3.
22.3. And if I take the square root of that, what's the square root of 22.3?
4.722.
4.722. Alright. So the standard deviation of my first group is 4.722. And I need to compare my standard deviation of my group 1 and my group 2 so I can tell which one has a more consistent height. So I'm not going to compute for it because I already have the answer for that one. So let's compare the values of their standard deviation. So my first group standard deviation is 4.72 inches. And the second group standard deviation is 3.35 inches. Now, by just looking at their standard deviation, can you answer this question of which group has a more consistent height distribution based on their standard deviation? Do you think it's the first group or the second group, and why? Now, the definition of the standard deviation is the average differences in each of the data sets from your group of data. Which one has a smaller standard deviation? Group 1 or group 2? Group 2. And in mathematics, the lower your standard deviation is, the more consistent, or as we call it, the less variable, or the variability is less when you have a smaller standard deviation. And when we say less variability, it equates to a more consistent data set. So between group 1 and group 2 students, My group 1 students, their average height difference is 4.72 inches. But for my second group of students, their average height differences is only 3.35 inches. So can you visualize the difference now between group 1's height and group 2's height? And that is because of the standard deviation. Lower SD equals lower variability. And when we say variability, it's their differences. And if we have a lower variability, it is we're seeing a more consistent height distribution based on this value. And that is the importance of the standard deviation in statistics or in mathematics. It gives us a numerical value that will describe the variability or the differences or average differences of each group. And in statistics, the lower the variability or the lower your standard deviation is the better consistency. And that is how you compute for the standard deviation. This is Dr. Esperanza, and thank you for watching my workshop on standard deviation. And if you need or want to know more about my lessons on mathematics, please like, share, and subscribe to my channel so I'll be able to help more students like you who missed this lesson on standard deviation or needs more practices on working with statistics.